Welcome back to another video. Today we are going to solve challenges from NULLCON CTF. Let's get started with our first challenge, which is Bfail. Let's open up the link. We have a form here, and if you see the source code of the HTML, we can find a comment which shows an endpoint called source. So let's open the endpoint. So as you can see, opening up the endpoint will give you a Flask application. Let's copy this code into a file and open it with an editor so that it is more readable. So in the code, we can see there is a admin password hash, and if we scroll down a bit, we can see the application's main logic. We can see the username and password being assigned. We can see checks like if username is admin or not, if the length of the password is greater than 128. And then we can see this function, which is the bcrypt check function. So let's Google if there are any vulnerabilities on this. So as you can see here, we got a GitHub link in the results. And if you open this up, in the comments, we can see that there's a mention that the bcrypt check function only uses the first 72 bytes of the password. So if we are able to find this first 72 bytes somehow, then we'll be able to get the flag. And if we check the code properly, we are able to find the first 71 bytes here. So if we can copy this and brute force that one last byte, then we will be able to get the 72 byte password. So this is that Python script which I have wrote to find that 72 bytes of the password. So this is the 71 bytes which we are already given, and I am adding that one last byte by iterating from 0 to 256. So basically after adding that byte, we are using the same vulnerable function. So let's run it and see what happens. So we found the password here. The last byte is 170. So let's try to send the username as admin and password as this and see what will happen. So this is a small Python code. We have the final password and the username. We are also using get as the method in place of post, because in the app you can see here only the method get is used. So let's run it. So here we got the flag as the response. So our next challenge is Crahp. Let's open the link. As you can see here, we have a source code available for us. It's a PHP challenge, and we have two functions named crc16 and crc8. So these two functions low-key generate checksums of the length, whatever they are representing. So crc16 basically generates a checksum of 16 bits, and crc8 generates a checksum of 8 bits. So in the main logic of the code, they are basically comparing our input password with the admin password which is present, and they should not be equal. But the hashes which are generated from the crc functions should be equal for both crc16 and crc8. So it is kind of a hash collision challenge. This is a Python implementation of crc16 and crc8. And in the main logic of the code, we are basically taking a parameter called target, and we find the crc16 and 8 for it. And then we find all the combinations of the same length of whatever target which we are providing, because in the PHP code we can see that there is a check which compares the length of our input password and the existing password. So we have to bypass that. So we have to use the same length. And on multiple combinations we'll be able to find it somehow, because the scope is very less for both the crc16 and 8. So let's run it. So this is an alternative password which has the same length as the admin password and has the same crc16 and 8 hashes. So let's copy this and try to paste it in the website. So as you can see here, we are able to get the flag, which means that the script has worked. So let's get into our next challenge, which is Numberizer. As you can see here, we are being asked to provide any 10 numbers so that they will add it up and give it as a result. So from the source code, we can see that they are getting a variable called numbers using post method, and it should be an array. And from the conditions we can see that the length of the number should not be greater than 4, and if it is greater than 4, it basically continues from the loop and it will not get added into the numbers array, which will be later used to calculate the sum. So the main goal is to overflow this sum variable and make this condition where sum is less than 0 as true, so that we can get the flag. And the best way to do this is to use exponents, because as you know, we can't use a number which is of greater length than 4. So if we enter 1 e to the power of 99 2 or 3 times, I guess we'll be able to overflow the results. And once we do that, we'll be able to get the flag, as you can see here, which means that we have successfully overflowed the variable. Let's solve our next challenge, which is chess.io. As you can see here, we got a source code. Let's open up this in an editor. I added few comments so that it is easy to explain. The code is converting the flag into an array of each element having a characters of 4. So as you can see here, each element has 4 characters. This function takes in an ID and it finds the first character of the MD5 of the ID. We are assuming it to be in the range 0 to 9. And in case if it exceeds that value, it will basically use a modulo function with the length of the seeds and convert it to 0, 1, 2 and so on. So from this index, it will basically get the characters from the seeds array and use that as the random seed for the randomness. And then it will generate 1000 characters from the alpha array or string and then returns the ID. This will be then set as the PHP session cookie and will be sent to the client. So the first step in solving is to generate MD5 hashes with the starting letter from 0 to 9, so that we can send the username and password and get the session IDs for each and every index of the seeds array. So this is the Python script which I have written to find the MD5 hashes. As you can see, it is taking index from 0 to 9. Here I have a loop which runs from 0 to 9. And as you can see here, it is basically checking if the initial word of the hash is the same as index or not, and returns the username and password and the hash value. When we run this, you can see that we have the username, the password and the hash values with starting from 0, 1, 2 and so on till 9. So now we got the hashes. We will go to the next part of the code. Before explaining this code, I have to show you a PHP script. As you can see here, it is finding all 4 character combinations and using that as the seed. The character set basically contains all uppercase letters, the numbers and the brackets which are required for the flag. It is using that as a seed here, as you can see, and it is then finding the first 10 characters which will be generated at random. As we are not using 1000 letters, this will reduce a lot of overhead for us. And we don't need 1000 because within 10 we'll be able to guess the characters. This code will then write the 4 character combination along with the random numbers which are generated into a output.txt. So as you can see here, the output.txt has all the key value pairs, and if you scroll down a bit, as you can see here, the ENO open bracket has a particular random character string, right? This string should be same as that of what we will get when the MD5 hash is 0 for the username and password. And in the Python code, as you can see here, we are trying to get the hash map loaded into the Python script. And if we scroll down, we are getting the cookies for all the requests for each and every username and password, which has the hash values from 0 to 9. And these will be used to send it to a function called find combo. This find combo function will then find a key value pair in the hash map which has the same value as the first 10 characters which we got in the cookie. It will then return a key combination for which the check matches. And this final string will be kept on adding the key which has been returned from the function. So if we now run this script, we'll be able to find the flag. So let's solve our next challenge, which is Paginator. So we are given a source code for this challenge. It's a PHP code. Let's open it up in an editor so that it is more readable. On the first glance, we can notice that they are using a database, and below that we have multiple queries. We even have a query about the flag, and we have multiple insert queries as you can see here. And all of these queries are into the table called pages. And if we see the main logic of the application, we can see that there is a variable called p using the get method, and it should contain a character comma so that it goes into the loop. They are basically exploding or splitting that into min and max. The minimum variable should not be less than 1, and if it is less than 1, it basically becomes not accessible. The max variable is assigned to the second part of the p parameter, which is after the comma, which means that it is injectable. We can have some malicious query in it, and we will be able to retrieve the data. So let's try it. Initially, we are passing 2 and 10 as the min and max, and we can see that we have retrieved all the data from id equals 2 to id equals to 10. If we use an union query here with all the records in the pages, we will be able to get the id 1 also, which is the flag itself in base64 encoded format. We can copy this and we can try to decode it. So basically I am doing a base64 decode. As you can see here, we got the flag, which means that the SQL injection has worked. So now let's solve the second version of the same challenge, which is Paginator version 2. Let me open the PHP code in an editor so that it is more readable. It's mostly the same code, but the flag query has been reducted, and they have added a new query called pages, which has created the table. And also the main logic of the code remains the same. There is no change in it. This means that we have to first find the name of the flag table and then retrieve all the contents of that particular table in order to get the flag. SQLite basically has a table called SQLite master, which holds all the names of the tables that are present in the database. So you might think that such a query might work, but the main problem is it won't. The main reason being the difference in the number of columns in the both tables. The pages has only 3, but SQLite master has more. So you might think we can basically match the number of columns in the retrieving data, but that won't work because commas are not allowed. You can find a workaround for this in the GitHub pages of Payload All Things. If you scroll down to bypassing firewalls, and you can see the section called no columns allowed. Here in the table you can find the last query similar to what we are trying to implement. So we can use this alternative query in place of using commas. In place of using commas, this uses join. So let's try this payload on our website. Basically, we are trying to get the names from the SQLi master, and we are getting null from the pages, which we don't want. And as you can see here, we are able to retrieve the name of the tables. Now that we know the name of the table that contains flag is flag itself, let's try to get all the contents from the flag table. The base64 encoded flag is retrieved if we use this query. Now we can decode this base64 encoded flag to get the actual flag. So this is the flag for the challenge.